That was awesome. That's the problem.
You guys wanting to learn anything today? Come on, let's go.
Sorry.
Holy crap. Well, I'm still going to assign the assignment. If you want to just try to figure it out on your own, you can. You're more than welcome to.
That would be difficult. That would be extreme.
It would.
Strenuous.
So let's shut the piles. We got 2 theorems to learn about today. One's called Rolle's theorem. Another one's called the mean value theorem. This word mean is the mathematical definition of mean. Average. Mean value is kind of like average value, right?
Yeah.
So those are the only 2 objectives. We have to learn what Rolle's theorem is and use it in some problems, and then learn what the mean value theorem is and use that in a couple of problems. Pretty short lesson. It's good because it's a short day. So, here we go. Let's do Rolle's.
Remember to record.
This is, thank you.
Okay.
Thank you.
Check in.
Rolle's theorem.
Good job for your checking on that. Thanks. Figure I should be have more presence of mind.
I actually kind of want to refer back to the quiz we just took.
All right.
Question number 2. I asked you to find the extrema on this interval. Where did the extrema happen to be?
On the endpoints.
On the endpoints of the interval. There was no extrema of this function inside that interval other than the endpoints, right?
Mm-hmm.
Or even though we got a critical value here,
Yeah.
so why did that critical value not turn out to be an extreme? It's undefined. Okay? But, so Rolle's theorem addresses that kind of. It says let f, just curious, sorry I keep going back and forth, why was that last question undefined?
Because there was a vertical asymptote.
Because it makes the denominator equal 0, and what did you say, Brake?
There was a vertical asymptote.
Wouldn't there be a vertical asymptote there?
Yeah.
Which means in this interval, is this function continuous on that interval?
No.
Yeah. Rolle's theorem says let f be continuous on. Did you just come in here and grab that peanut butter? I wondered whose that was. Okay. Anyway, let f be continuous on the closed interval. AB and differentiable on the open interval AB. So that question we had at the end of the quiz, question 2, would that question apply here?
Yes.
Question 2, would it apply here?
Wait, that's not continuous. No.
It's not continuous, right? But f is continuous and it's differentiable between a and b. So what this theorem says, if f of a is equal to f of b, what does that mean, by the way? There's a then part of this. There's an if part and then a then part. But what does that if part mean?
If the function is equal to each other.
Well, are we talking about on the
So the two endpoints make the function.
right now, I'm thinking on the closed interval, the 2 endpoints, so on the open one, it's the 2 points you chose on a continuous line.
Okay. So what if we had f of a right here, then where does f of b have to be? According to this, same exact height, right? So in between, isn't the graph continuous?
Yeah.
So the graph might be going up and down a little bit, but it starts and ends on the same vertical distance. So what do you think the then part of this is going to say? If f of b is equal to f of a, then...
The line is continuous between f of a.
Okay, true. Then the graph's continuous between f of a. We just finished talking about extrema, and we saw a problem on the quiz where the extrema were the endpoints, right? Because it wasn't continuous in between the endpoints. But if it is continuous between the endpoints, and the endpoints happen to be on the same vertical, then Rolle's theorem says it's guaranteed that there are going to be some extrema in between the intervals.
There are each.
So then there is at least one number C in the interval AB such that f prime of C is equal to 0. Now that's just fancy math talk for... What does it mean that f prime of C is equal to 0? What does that mean C is? It's an extreme. Okay? Or at least it's a point on the graph where the derivative, the slope, is equal to 0. Okay? But it has to be true that f is continuous on the closed interval. Like we saw on the quiz, if it's not continuous, then it's not guaranteed that there's a number between. So here's an example. It is possible. Yeah. It will come up probably later. Let f of x equal x to the 4th minus 2x squared. Oh, this is kind of just like what you guys did yesterday. Oh well, we'll start with an easy one. Find all values of x. Or sorry, just find all values of c in this interval such that f prime of c is equal to 0. So let me explain why this problem is even here, because it seems like just stuff we did last time with finding critical numbers. Is it even guaranteed that we're going to be able to find any values of c, f prime of c, that's going to equal 0?
No.
So if why would we go through the trouble if it's not even guaranteed that this is going to work? So maybe we could apply Rolle's theorem. Because if f of negative 2 equals f of 2, then doesn't that guarantee that in that interval there's going to be some of these values where c, f prime of c equals 0?
Yes.
Yeah, so it's like doing step 3 first.
Okay.
Essentially. Basically finding out if there really is something you're going to find out.
Okay, yeah. So
Yeah.
what is f of negative 2 and what's f of 2? What's f of negative 2 and what's f of 2? Come on.
F of negative 2 is, oh shoot, this is hard.
It's not that bad. F of negative 2
16. 64.
is 16 minus
8.
8, which is
8.
8. And then f of 2
16 minus 8
is 16 minus 8,
gives us
which equals 8. So what this means is f of negative 2 equals f of 2.
Yeah.
So that's Rolle's theorem right here. F of A equals f of B. That guarantees that between those 2 points, A and B, there's at least one number
We win.
such that f prime of C is equal to, what this means is it's guaranteed that there's going to be a critical value in this interval -2 to 2. F might have critical numbers. I'm not saying it doesn't, but how do we know that they're between -2 and 2? How do we know that there is going to be at least one of them between here now? Because f prime or f of -2 equals f of 2. So let's see. How do we find these? What did we do last time to find critical numbers?
You have to find the derivative of the first equation.
Find f prime of x and set it equal
To 0.
to 0. So f prime of x is 4x to the third minus 4x. And now we set that equal to 0.
Pull out of 4x.
And you factor out of 4x. You guys finish that one up.
Got it. So then we plug those back into that equation.
Well, all the question was asking is to find all of the critical numbers essentially in that interval.
I really want to find an x.
It didn't ask for them.
Was he? Got it. Just figured it out in my head. So mathematically speaking, figured it out.
So x equals 0.
Because I was like, why can't you take both
X
those
equals
things
1.
and say they equal 0? Because
And x equals
equation 0.
-1. Now you guys, you need to get used to making sure that you're actually answering the question. They didn't just say find all the critical numbers. They say find all the critical numbers that happen to be in this interval. These are all the critical numbers of the function. Are all of them in that interval?
Yep.
They are. If you happen to have a couple critical numbers that aren't in the interval, you got to make sure that you only answer the ones that are in the interval. Does that make sense?
Yeah.
But all of these happen to be in the interval, so we take all of them. All right? That's about really all you're going to use Rolle's theorem for.
So it's kind of like with synthetic division where you like, never mind, to me it kind of makes sense. Like the px over q of x, or no, p over q or whatever, q over p,
Okay.
and you can find all the possible answers or zeros.
Yeah.
It's kind of like that, just so you know that there's zeros or not.
Yeah. Yeah. I see what you mean.
It's kind of.
I see what you mean. Okay.
You're right,
Let's go on to the next theorem, the mean value.
That's really good shit. No, I thought we were at high school.
The mean value theorem. Okay. This one says if f is continuous on the closed interval AB, and it's differentiable on the open interval. So it starts off just like Rolle's theorem. Then, remember what I said right at the beginning, what mathematically mean? The average. So then, there exists a number C in the open interval AB. So that means C cannot equal A or B. It's between A and B. Such that f prime of C is equal to f of B minus f of A all over B minus A. This should look familiar to you. I hope you've seen it enough in pre-calculus and this year in calculus. Does this look familiar? FB minus FA all over B minus A?
Looks very familiar.
It's the average rate of change.
It's
Right? Do you remember that?
Changing.
Average rate of change between two values on a graph.
Oh, man.
So let's draw a picture of this. Come on, get drawn. Get drawing. This was way back in like the first lesson, maybe the second lesson, but if I wanted to find the average rate of change between point A and point B, then don't we use this formula here?
Yeah.
Okay. What kind of a line is it called that goes through 2 points?
Linear line. A straight line.
I don't know, maybe we didn't go over it. It's called a secant line.
Oh, yeah.
Dang it.
Did we go over that?
Yeah, we did.
So this right here, I want you to label that as the secant line. What's it called when a line just touches the edge outside of a graph at one point only? That's called the tangent line. Now we've been talking a lot about the tangent line because that's what derivatives are used for, to find the slope of a tangent line, right?
Yep.
But how do you find the slope of a secant line?
Integral.
You just use a little function thing right here.
You use the average rate of change point right here.
Yeah.
This will help you find the slope of this secant line, won't it?
Yeah, it will.
Because isn't this a change in y divided by a change in x?
Yep.
Anyway,
And
Slope of the 2
derivative of
points.
C is the slope.
what this theorem is talking about, you guys need to understand this. You see what I'm circling here? This is a change in y divided by a change in x. What is a change in y divided by a change in x?
Well,
It's a slope. Okay? So if this is a slope, and then you have f prime and you plug a number into f prime, what happens when you plug a number into a derivative? You find the slope of the tangent line at that point.
yeah.
Are you guys following this? You need to understand this. This is a slope, and isn't this a slope?
Yeah.
And if they're equal to each other, what does it mean when two lines have equal slopes?
They're parallel.
They're parallel. You following?
Or they're
Yeah.
So the mean value theorem says that the slope of the secant line between point A and point B, there's a number between there such that the tangent line has the same slope as the secant line.
Okay.
There's some number C between A and B. Like if I put C right here, does that tangent line have the same slope?
No.
So that's not where C needs to be. Do you understand what I mean?
Yeah.
C is somewhere in here such that the tangent line is parallel to the secant line. That's what this is saying.
That's really weird.
So
And how does that find the average?
maybe like right here, if I had drawn that a little better. So let's say that C is right there. So the slope of the tangent line at C is equal to the slope of the secant line between A and B. That's all this theorem is saying.
Yeah.
Okay? And it actually does turn out to have a few useful purposes. The main purpose of the mean value theorem is to prove a lot of other theorems in calculus, and because of that, a lot of people consider this to be one of the most important theorems in calculus because it's used to prove a whole bunch of other ones. But There are some practical applications that we'll talk about here.
And so wait, which one is the average?
This is the average rate of change because it's a secant line. This is an instantaneous rate because it's a tangent line.
So if every single tangent was around in that interval, that would be the average of that secant line?
Okay, yeah. The average rate of change, I guess, could be the average of the instantaneous, but there's an infinite number of instantaneous rates of change between those 2 points. But yeah. Let's do example 2, 3, 4. 2. Given f of x is equal to 5 minus.
Can I get Gabe Summers to come to the front office?
Yeah.
Thank you.
Finally figured out, Gabe.
He's finally getting asked to say these.
Find all values of c in this interval such that f prime of c is equal to f of 4 minus f of 1 all over to 4 minus 1. So first we got to figure out what this is. What's f of 4 minus f of 1 all over 4 minus 1?
1.
You're saying it's 1?
Yeah, so f of 4 is 4 minus 1 is 3. It's 3 over 3.
Well, we have 4 minus 1 down there on the bottom. 4 minus 1 is 3. That's the easy part. You plug in a 4 first for this x. 4 divided by 4 is 1, so 5 minus 1 is 4. Now we subtract whatever f of 1 turns out to be.
4 over 1 is 4, 5 minus 4 is 1.
If x is 1, yep. If x is 1, 4 divided by 1 is 4. 4 taken away from 5 is 1. Equals 3 over 3. It's equal to 1. So what this is saying is find all values of c such that f prime of c is now equal to, instead of this, it's...
Oh, so it's kind of like what we did last time, but instead of saying equal to 0, it's equal to 1.
Yeah. So we just got to find all the values of c such that if you plug them into the derivative, it would equal 1. Now, how do we know that there's even going to be a number in c such that the derivative of c, or the derivative of f at c, is equal to 1? Well, we have to make sure that the mean value theorem applies. Is the function continuous in this interval?
Yes.
Where is the function not continuous?
0.
0, but it's continuous in this interval, right? And it's differentiable?
Yeah.
And those are the conditions for the mean value theorem. F has to be continuous and differentiable in that interval. And it is, right? So according to the mean value theorem, it's guaranteed that there's going to be a number between 1 and 4. There's a number c in that interval such that f prime of c is equal to this now. So we know that we can solve it. So the next step is to find the derivative of f.
Oh, jeez.
Find f prime of x. Say that again. The quotient rule? You could.
Students, you should be going back to second hour. First assembly is over, teachers. They should be returning to second hour.
You get out at 10:16. And then you go to
lunch.
No, then you guys go to, no, you go to the second assembly. Yeah, and then either you have lunch or third period after that. So anyway, come on.
Alright. Okay, so f of x, that's going to be,
We got to find that prime.
So, derivative of 5 is 0.
we're going to do the quotient rule.
Easy
quotient rule.
I would actually, well, you can do it however you want. If this were me, I would probably change this. Isn't that the same? It might be a little bit easier to find the derivative now. I mean, you could use quotient rule if you want, but would you maybe agree this might be a little quicker?
That might be. That probably is.
So then, the derivative of 5, so that just goes away. F prime of x now, but when you drop down the -1 to the -4, it becomes 4 x to the -2. So it's 4 over x squared.
And then, you've got to plug in, oh, you got to make that, set that equal to 1.
I was going to say, do we plug in the 1?
Set it equal to 1.
We want to set this equal to 1. So now we have to find out
Equals x
where 4 over x squared is equal to 1.
plus or minus 2. And that gives you, that's those are the two values.
Can you set x squared?
Or you multiply both sides by x squared.
Or 4?
You multiply both sides by x squared.
Which gives you 4 equals x squared, and then you square root that. Plus or minus 2.
4 equals x squared. So x is equal to but they only wanted to find values of c in
interval.
1 to 4.
-2 is not.
So the only value of c that we're going to use, or the only value of x in this case, is x equals 2.
And then we plug. Oh no, that's it. But that doesn't make
That is the
sense.
slope
Oh yeah,
of
it
the
does. Because you gotta
line
take 2 and plug that back into the
that
derivative.
touches c, the end of the secant.
Okay, yeah, it looks like some of you guys have... What was the slope of the secant line? The slope of the secant line was 1, right? What would happen if I took this number 2 and plugged it into the derivative?
It would be 1.
Equal 1.
It would be 4 over 2 squared, which is
4.
4 over 4. 4 over 4 is 1. So what's the slope of the tangent line at this point? 1. So the slope of the tangent line was parallel to the slope of the secant line at an x value of 2. What's the y value? Plug it back into the original. 4 over 2,
2.
5 minus 2,
3.
at 3. So you would say at the point 2, 3, the slope of the tangent line is parallel to the slope.
Jump in.
Parallel to which slope? Slope of the secant line for the interval 1 to 4. It's only for the interval 1 to 4.
That's a pretty long answer. Would you expect us to write this whole answer on the...
Well, no, the question was only, I was just kind of explaining something there. The question was only asking, find all values of c. What was the only value of c that we found? X equals 2. Here's a practical application. Even though I disagree with, well, it's correct, but I think it's mean.
I think it's me too.
But here's a practical application of, it's kind of entrapment, I'd say. Well, let me write down the problem, you'll see. 2, maybe I just don't understand what entrapment means. 2 stationary patrol cars. You guys see where this is going?
Start driving.
Equipped with radar guns
Oh, Mr. Huck hates fools.
I do.
He hates them.
Are 5 miles apart
That isn't traffic.
on a highway
Notice the sound of speeding.
So you guys visualize the situation here? So as a truck passes the first patrol car, his speed is clocked at 55 mph. Four minutes later, when the truck passes the second patrol car, its speed is 50 mph. The question is, what color shirt was the driver wearing? Using the mean value theorem. Prove
It was brown. Because
prove that the... Hey, you guys. The speed limit is 55 miles per hour. Okay? If you're just looking at the radar guns, if he's going 55 miles per hour in the first patrol car and then 50 miles per hour in the second patrol car, you might think, well, he's okay. Right?
Yeah, he's fine.
Because the speed limit is 55 miles per
I would
hour.
have been vomiting in between those and just slow it down when we got to the next patrol car.
So our task is to prove that the truck must have exceeded.
Oh, these cops are jerks. They're gonna pull him over?
Yeah.
I'm doing all these. They're laughing on
They're
it.
doing all this math. Must have exceeded the speed limit
Must have.
You must have been
Based
going
on these two.
of 55 miles per hour
Oh my gosh.
at some point
Worst. In the future, all cops will be mathematicians.
between.
You just have 2 cars drive and all of a sudden they're like,
This is an
you
illustration
got them, they're like, oh.
of the mean value theorem. Okay, you guys, this is an illustration or an application of the mean value theorem. Okay, we know its instantaneous speed at the 2 endpoints, the one patrol car and the other patrol car, right? But the mean value theorem says that at some point between the endpoints, there's a value c such that that instantaneous rate of change is equal to the average rate of change. Isn't that what the mean value theorem says?
Yeah.
So all we know is his instantaneous speed at the 2 endpoints. What was his average speed between? Do you see where they're going with it? If we can calculate his average speed between the 2 patrol cars and his average speed is above 55 miles per hour, doesn't that mean that at some point between the 2 patrol cars he was going faster than 55 miles per hour? That's what the mean value theorem says.
The average
We're
speed.
playing the average. Oh.
So his instantaneous speed at the patrol cars might have been under the speed limit, but if his average speed between the 2 patrol cars was greater than 55 miles per hour, then the mean value theorem says there exists a number between the 2 points such that the instantaneous speed is equal to the average rate of change, right? So we need to calculate the average rate of change. So let's let t equal 0 be the time. Yeah. Okay. When the truck passes the first patrol. In hours. Come on, focus. If time equals 0 when the truck passes the first patrol car in hours, when did the truck pass the second patrol car? In hours.
It was 4 minutes later, so you gotta divide 4 by 6.
It was 4 minutes later. So how much of an hour is 4 minutes?
4/16.
You understand what I'm saying?
Is 1/15.
1:15.
It's 1/15 of an hour. 4 minutes out of 60 minutes is 1/15 of an hour. So t equals 1/15 of an hour is when the truck passes the second patrol. Okay. So we have a distance of 5 miles. We know it took him 1/15 of an hour to go that 5 miles. We need to calculate an average speed. Where are we going to go here? How do you calculate a rate if you have distance equals rate times time? Distance equals rate.
You know the time with the rate, you have to find the average.
That's what we're
Which is what we're doing.
That's what we're gonna do.
So we're going to find the distance that you
So
travel.
you gotta take the total time.
We know the distance he traveled.
5 miles.
Where's the distance?
5 miles.
Oh, 5 miles. Oh.
5 miles apart. So we know he traveled 5 miles in 1/15 of an hour. So then what was his rate? What was his average rate?
Is that the rate?
Isn't rate equal to d over t?
Yeah.
Around 5 miles.
So it's times you gotta go
So what was his distance?
5 divided by 1/15.
Which is just fine.
His rate, his average rate is equal to 5 divided by 1/15, which is
That little.
75 mph. So his average rate, or his average velocity between those two points, he may have been going 55 miles per hour at the beginning and 50 at the end.
So he was going
But in between, his average speed,
Is it average?
his average speed was 75 miles per hour.
So, if
This is right
speed
now.
is not 0,
After you pass the second comma, then you get the radar,
You can let
and you just go like 90.
you can let t equal 0 because that's at the beginning.
It's how I'm
When
going
you started.
50 miles per hour. Perfect, right in time.
Yeah.
Like just called it.
Yeah. Hey, bell's gonna ring here in like 30 seconds. We gotta wrap this up. You guys, this is just his average speed. But according to the mean value theorem, isn't there a point between the endpoints where the instantaneous speed is equal to the average speed?
Yeah.
So we don't know exactly where it was, but at some point he was traveling 75 miles per hour between the two patrol cars, so he exceeded the speed limit, right?
Yeah, pull him over.
So they pull him over, those jerks.
I love cops.
I want to be a cop when I grow up so I can pull people over like Mr. Love.
And I'll do math.
And just say, I knew you were going 5 over, but I'm going to write you up to 30.
If you're insubordination,